So students, good morning. I am going to explain something about the titration. You know titration? It is a way to find out the strength of an unknown solution by using known solution. So it is a way to finding the strength of an unknown solution by the help of known solution. And so it is defined as a way to find out the strength, of an unknown solution. So one solution is unknown. We don't know the strength. With the help of a known solution is known to us, and that known solution is called a standard. The solution which is known to us, it means the solution whose strength is known to us, whether it is one normal, two normal, semi-normal, decinormal. So this is very important part, that the solution which is known to us is called a standard solution. Now titration is of two types. It is of two types basically in normal courses. So here first is neutralization. Titration. Neutralization titration, or it is called an acid-base titration. It is called an acid-base titration, which we have seen in class 11. Now second is redox titration. You know redox titration? Redox titration means we use oxidizing and reducing agent. The use of oxidizing and reducing agent is basically called as redox titration. We use oxidizing agent, we use reducing agent. If one is undergoing oxidation, other must undergo reduction. And so it is redox titration. And so redox titration is very much important for class 12. And so redox titration is basically done in slightly different way than that of the neutralization titration. It requires some medium. So we will focus on the redox titration. So it requires some medium. You all must be knowing. Redox reaction takes place in acidic medium. It can take place in basic medium. But in neutral conditions, it is not so easy in laboratory. So in class 12, redox titration is of two types. One is FAS versus KMnO4. FAS, ferrous ammonium sulfate. Ferrous ammonium sulfate, commonly it is called as Morse salt. And it has the formula this is Morse salt. This is so FAS here. FAS is here. It is reducing agent. It is reducing agent, and this KMnO4, it is oxidizing agent. oxidizing agent, and it takes place in, here we allow the reaction to participate, to occur in acidic medium. It is in acidic medium. So this is one titration. Now second titration, it is oxalic acid. Oxalic acid. So here oxalic acid, oxalic acid, it is dicarboxylic acid. It is dicarboxylic acid. Dicarboxylic acid, oxalic acid, COOH, 2H2O, and it is reducing agent. It is reducing agent. So here, of course, we'll change the oxalic acid. Oxalic acid is dicarboxylic acid. Now, children, in Redox titration, there is a point that here we do not use indicator. No indicators. No indicator is used. No indicator is used, as KMnO4 has purple color. KMnO4 has purple color, and KMnO4 is taken. It is taken in burette. It is taken in burette. This is first point. Second point, FAS or oxalic acid, they are colorless. They are colorless and taken in flask. It is taken in flask. Then dilute sulfuric acid. Dilute sulfuric acid, approximately 3/4 of test tube. 75% of test tube is filled with dilute sulfuric acid and is added in this FAS or oxalic acid. Oxalic acid and FAS before titration. So these are the basic points. It is taken, it is added. So otherwise, the procedure is same. Simply, we rinse all the apparatus. We fill the burette with KMnO4. This is one. Second point, take the FAS or oxalic acid, 10 ml or 20 ml as per our convenience, and keep in the or transfer in the titration flask. Then add 3/4. You may take one test tube. It is dilute sulfuric acid because reaction takes place in acidic medium, and then it is titrated. Then we allow drop by drop KMnO4 with a constant stirring. Otherwise, process remains the same. And what happens? As we keep on adding the KMnO4. So KMnO4 it has purple color. KMnO4 has purple color, and so the end point is appearance of light pink color. Light pink color, just light pink color. The color of more salt solution or the color of oxalic acid solution becomes pink. And care has to be taken that if we add 1 drop of more salt in the pink solution, it will become again colorless, or oxalic acid, it will become colorless. Because if the concentration of KNO4 is increased, then it will become pink. If the concentration of oxalic acid 1 drop is added, it will turn into colorless. So this is very important part in this aspect. Now second important part is we heat the mixture of oxalic acid, and H2SO4, mixture of oxalic acid and H2SO4 before titration. Before titration, up to 60 to 70 degrees Celsius. This is very important point. 60 to 70 degrees Celsius. But we don't use thermometer. So this upper part of our palm is sensitive to temperature around 70. Just you take the titration flask, warm on the burner, then bring near the titration stand quickly, don't waste time, and just with constant stirring allow the KNO4 to add drop by drop, and then you can get this point. And so we do the test. We calculate the strength by the same condition. Molarity equation M1 V1 is equal to M2 V2, and so you can find out the point. Now I am coming to the technical part of this titration. We will write down the chemical equation. So we either write ionic equation or we write the molecular equation, and so it is written like this. This MnO4 permanent ion, it is released by the KNO4. It is oxidizing. Then more salt will give the ferrous ion. More salt will give the ferrous ion. Here in acidic medium. Then they will be changing to this Mn2. Then Fe plus 3, A plus 3, and then there is of course water. Now see, here the oxidation number is plus 7. So plus 7 has reduced. It has been reduced by 5. Decrease in oxidation number. So it is reduction. So now here, this Fe2, it has converted to 3 plus. It means it is increased by 1. So increase in oxidation number. It is oxidation. Now children, this MnO4, it has purple color. This Mn2, it is colorless. So this is the ionic equation, and this you have to write down. This has to be written in the equation. One equation, this ionic equation, so it has to be written, and as a result we calculate the different conditions. So first we use the molarity equation, and so here there will be change. So here it is decreasing by 5. So we multiply by 5. In order to it, we multiplied by 5.